I'm going to go over a few of the slides to just get you started. Then we're all going to go switch over to Simulink. Okay. So how many of you have used Simulink before? Just raise your hand. Great. So I don't have to like explain everything. That's great. Classroom, Katie, you did. Okay. So this is, again, as usual, making sure I bring everyone up to the same level, right? So it's kind of introduction. Now, if you have used Simulink extensively, you know what to do. At the end of this slide, I put a link that you will build a PID controller and tune that. You can just go ahead and do that one. All right. If not, or if you want to just go with the flow and see like our introduction, you can just listen in. All right. Okay. Jesse, do you have a question or is it for the Simulink? Okay, just for the Simulink. All right. So I'm going to use my laptop only, and I'll have my iPad just for it. All right. So Simulink is a tool that helps us visually see the performance of our system and tune our system using MATLAB Toolbox. So we will basically be in S domain and build a block diagram of our system. Now, our system has plant, controller, input, output, feedback, sensors. We also sometimes will add noise. Dr. Z wins. We have noise that we will add that to our system, but we will start from a very simple system today. All right. And then once you know the direction, you're able to build any of this block diagram we had in the course so far. Any of the equation, differential equation, you can convert it to block diagram. So to me, this is the opening the window or the door of that opportunity for you. And I will expect you for practice, do some of those. So for practice, once you learn this, you can actually solve the last two practice problem from the lecture this Friday, from Monday, that I didn't solve it. You can solve those using Simulink. All right. And you'll see it's a lot simpler when you use the software for that. Now, once we get to Simulink, you have two different ways of launching it. One is from the homepage. You can do that, or you can type in the command Simulink. It is a little bit slower, so it will take time to load, but once it's there, we can go ahead and start. You will get to this start page. We always start from a blank model. Once you click that, this will appear. Now, there are a couple of things on this slide, on this that are important. One is here, this white, blue, and red color, that's the library. So we will bring all of our blocks, everything we need from here inside into our model. And then once we are done with all of those pieces, we close the library and start connecting the blocks, setting the initial conditions, the time of the simulation, and then run. All right. There are basic elements in your model. One of them is lines. So lines are signals. The direction of the lines are important. So there's always an arrow that shows the direction, which is the direction of your signal. Now we are dealing with single input, single output signals. So they are scalar. They just carry a value to them, right? You could build for MIMO system, multi-input, multi-output, but you need to use some specific blocks in Simulink to do that. So for now, we're just going one line, one signal at a time, all right? You can't connect a signal to another signal to add them. If you remember from our block diagram math or algebra, if we needed to add, we needed to use summing point or deduct. But if you take off a signal, a line from another line, what does it mean? What's the value of the two lines? It's the same, right? So if you grab a line from another line, it's the same signal. If you need to do any addition or deduction, you have to use the sum block. Now, sum blocks have signs, plus and minus. So, and you have to pay attention that there are default values, and if you need a value to be negative or positive, you have to actively go and change it. We will practice that today. There's what else? So, as you can see here, for example, we have some blocks that act as input, some blocks will show you the output, and then there are some blocks that they build the system. These are three different categories. The one that generate signals or are input are called sources. So in your library, when you go to source, you can see all different signals. So you can, if you need a step, there is a block called a step. You can adjust what's the amplitude of your step or for how long you're gonna have the step input. There is ramp, sine wave. There's also a signal generator that's empty. You create your own signal, however you want it to look like. All right, so those are your sources. Then you have your sinks. Sinks is where you see your output or displays. So you can put your output in a variable. You can put it on a display so you can actually see the plot, right? And you can send it from one place to another place. You can use continuous and discrete functions, values in here. So be careful when you're bringing a block. If you are working on a continuous system, you pick that block. All right, because we have the same for discretized system as well. You can use math operations, and you can also use ports and subsystems. So if your system becomes really big, you can put it under a block called subsystem and then just send an input and output to that subsystem. That's just more for organizing. That's basically all of those are in your library. So if you look, you'll see that you have common use blocks. So once you start working, the blocks that you usually use will populate there. So do you remember that we went through this, like building, like drawing the block diagram from a time domain differential equation? So basically, Simulink is the same thing. You are in time domain. You will convert time domain to S domain, and then we use this environment. Now, let's say that we have x dot equal to sine of 3t minus 4x, and we have our initial condition. So for Simulink, you need to define your initial condition, right? So you start from 0 value at time 0 for x. X here is your state, right? It matters now. Now we understand what the state is, because once we solve this, we are seeing the performance of our x, our state. What's the input here? First of all, is this linear or non-linear? Is it LTI or not LTI? You remember? Is this equation LTI or not LTI? So dx to dt is x dot. Is it linear? No, it isn't. Remember, for differential equation, you had to look at the coefficient. If it was just a constant number value, it was linear. If the coefficient was a function of the state, for example, sine of x times x of t, then becomes nonlinear, right? So right now, our state is x of t. So -4 is a constant value. Then x dot, which is 1 times x dot. And then how about 2 sine of 3t? It doesn't have our state. What is this? Amber, what is 2 sine of 3t? Yes, it's your input. So you see, here it's important to understand what is the input, because we have to build it. Why this is the input is not a function of our state, right? Because our state is x of t. Now, as a function of time, because this is in time domain, like you have to change time to generate something, right? So the input to this is 2 sine of t. Now, you can rearrange this and say that x dot plus 4x is equal to 2 sine of t, 3t. Make sense? So one side is your differential equation, the other side is your input. Now, the differential equation is your system. 2 sine of 3t is your input to that system, which you can change it and see a different performance, correct? Now, if we want to solve this one, we have to take integral, right, for x. So now that integral action, we know that in block diagram is basically, what is the integral block? Do you remember what was the transfer function of integral block? 1 over s. So here, x prime, so you have an input, right? that could be 2 sine of 3t. You have your x prime being integrated and then becomes x, your output. So starting to build the block diagram, right? We have done this, so I expect you to remember that. So this will be the block diagram of that equation. Now, the only thing that's missing is what is this integral block, which is 1 over s. So you will grab integral. There is an integral block. You grab that and put there. And you see the sign of this block, this summation point. We will see when we get there. If you double click, you can actually change the sign there. So we know this is a negative 4x, so negative, so it's 4 times this times 4, so gain time x, negative sign, plus 2 sine of 3t becomes x prime. Okay, so we have done for more complicated equations, so this shouldn't be any problem for you. Now, how do you see the output? You can put a scope plot and see the plot of how the output looks like. All right. Okay, we are gonna build this. Now go to Simulink. You can have this open, so if you have to go back, we are gonna use a couple of blocks to build this. Things that you need to find is an integrator block, sum block, gain block, sine wave block, and a scope. And they look like this. Bring all of them to your model, empty model. So if you click on them, you can also drag them. What are the questions on Zoom? Brett? Oh, answering questions, okay. Okay, same for classroom in Zoom. Do the same thing. For now, just bring the blocks and then we will do the rest together. All right, I'm gonna go walk around the class and see how's everyone doing, and then we can do the still, yeah. So if you're using MATLAB online, it's fine, but I want everyone to is there any line for you to open MATLAB? Is there a message? Yeah. Until Monday. Technology. I think our expectation is too high now. Everything needs to open right away. Because I remember using dial-in internet. I'm that old. The sound of connection, huh? I would work, I don't probably remember, but we were one of the first families in the city that had computers. So, that is.
I have a question. My mom plays
Okay, I'm not that old, but I remember in high school, or middle school, the most exciting thing for us was to build open paint, and I draw a parrot, and then we use this spray, create the movement for the parrot, and they thought it was yeah, from that. So, but I learned Q Basic and DOS as part of my computer adventure, because that's what all existed. Before Windows. So I'm the generation before Windows. I just recognized.
It must have been very dark.
Actually, it was nice because nobody expected you to find all the information quickly, because you have to go to the library. All right, if you have done this, go to, if you haven't followed the lecture, so I'm moving on with those that have done this, all right? So, we are going to connect things together. Now, connect the output of the sum block to the input of your integrator. So you can hover around the output and then you see the dash line, you can double click or grab it, connect it to the other block. Then connect the integrator to your scope and rotate your gain. Connect one side of the gain to the signal that goes from integrator to the scope, and the other side of the gain to the other side of the sum block. So everything should be connected. And change the value of gain to 4. You will double click on, and then you can see where you can change the value. What time is it? 2:30, 3:30. I don't know about that. Okay, I'm going to perhaps, oh, what is this? So I don't think Zoom Classroom is seeing this, it's just me and you can see it. I'm gonna build the same model. Zoom Classroom, we are on slide 11. Connect everything together. Yes, Zoom Classroom can see this slide. We are doing something different in the class. Bringing gain. Scope. Sum block. So, I'm missing a bunch. Raise your hand if you built everything connected. Okay. Yeah. No, I'm not meaning to share this. No. I'm gonna do the same thing, connect, and then I will share this once I have it. Also rotate it. Rotate button. How did I say rotate this? Rotate. Yep. Thank you. You're a genius. All right, so I'm going to now share this screen with them. So you don't have to see me go through all of that. All right, so everybody sees the model. So double click on your gain, and then you can change the value to 4, and you can see other things there too. So for now, we are just changing the values. We can connect our Simulink model to our MATLAB code. So if you run a code in your MATLAB and say that you introduce a value m equal to something, and put m here and connect that m to the workspace in MATLAB, it will copy it here. So a lot of time that's we build a general model and then we change our numbers in our code. All right, so this is how do you connect the attributes. Right now we are not connecting anything, we're just using a single value, and you see that all the multiplication here are element wise. This is a gain. All right, and this is sum block. I can change the sign, so plus and is going to be minus. You can change the shape from round to be rectangular. I like round. There. Now go to your integrator block, double click on that and see what's in there. So you can see if you're following the lecture, it's already there. So our initial condition, it's important when we take the integral, right? So here, the initial condition, we are gonna set to, did I say 0? Yes, so initial condition set to 0, and we are gonna hit OK, which I cannot do that because this is too small. Okay. Now, go to your sine wave, double click on that, and in your sine wave, you can change the amplitude and frequency of your sine wave. All right. In all the sources, all the inputs, you are able to change those values. So for step, the value is 1, but sometimes the amplitude of your step, for example, is 10. You have to go and change that. And also for step function, define the time that that step function is running for. For example, like 10. That will be 10 seconds for 10 amplitude of 10, for example. All right. So now go here, set the amplitude to 2 and set the frequency to 3. So it's 3 radian per second. And let's see, how can I get this? Say hit OK. This is confusing, complicated. All right. Apply and OK, use external signal. No, use simulation time. So MATLAB, you can use a Simulink for hardware in the loop application. If you're doing that, then you have to change your time to external signal if you are coming from a signal generator. But since we are just using simulation time, I'm going to say simulation time and then hit OK for that one. What did I do? I broke it, sample based, because it's time based, it's not sample based. I can fix when I break. And then the scope is just a scope. All right. So it will print in something like this. Now, we have set those. Now we can run our simulation. All right. Here at top, you'll see that you have stop time. So this is your simulation top. Let's run for 10 seconds. Hit the run button. And the scope will show you solution. All right, you all have to get something like this. All right, now you'll see that the lines are broken, right? They're not like smooth. We can fix that. Now, the thing is, MATLAB uses a solution method when it's solving this. MATLAB is basically solving this equation, right? Now, we can go to the setting and change this value. So we can click, close this. If hold on, where's this setup? Simulation configuration, view configuration properties, and then no model configuration. In the wrong spot. Stop. I just want to show you the method that it has to be run. Oh, here. So this is the method that MATLAB is solving, is using OD45. We have used OD45 in one of our assignments, right? Not, yes, very beginning? I think so, we did. So you can change that as well. And so we have to go to model configuration parameter, which I think has to be in configuration properties, if I'm not wrong. Might be wrong. Can't find it. Somebody. Where was that? Should be one of these. Configuration parameter. Data import export. This part is different from, I think it's here. This part is different from if you're running on MATLAB on your computer rather than the online. You just need to find it online to change the. Can you see that configuration, model configuration parameter? Is anybody using MATLAB on their computer? Can you find that on here? Because it should show, but it's not. I seem to be able to find it. Simulation. Setting. Okay, here. So it's different from if you had MATLAB. Okay. It should be usually under the simulation, but here's under modeling for MATLAB online. So you'll find this window. And then under data import export, your refining value, which has to be in this additional. So the refine factor has, you can change it to 10 from 1. 10. This just refines your output. When you run again, it will look smooth. Apply, okay. If I run again, simulation, run, it should smooth out my scope. Now it's better, right? So you could like you should have been able to find from simulation here, but it wasn't here. So go to modeling if you have modeling up there. If you don't, it is under model setting. So I don't know if on the like actual MATLAB, where is it? But if you're using MATLAB online, is under modeling, model setting. And if you click, this whole thing shows up and it will be under data import and export. And all the way to the advanced parameter, additional parameter, sorry, that refine factor, change it to 10. So it's just show more data, basically, plot more data. On the, so Sam, where is yours? Is it the same place? Okay. All right. So model settings. Now, this is if you wanted to have a scope. Now, go to back to your library and add that to workspace. So when you say workspace, you're saving it in a variable that if you're running the code, it will create a variable on your MATLAB script, like a MATLAB library workspace. So the Y value will be all the solution of this. All right. Now, do that. And what I want you to do is to go to one of the examples we solved on either Monday or Friday and build the transfer function of that system with the control you had. You had K, so you give K values and then plot and see the response. All right. So it doesn't have, you're not designing any controller yet. You're just building a more complex model. And I want you to use the step function and run and see, right? So you can use one of those that had noise from the environment, and you would set your, for example, input equal to 0 and see the effect of the disturbance. You could do one of the examples, right? So choose your favorite example and I walk around and look what you're doing. Seth, what's your question?
For the Y out there, I searched it. The one, the particular one was
Yeah, let me see. Hold on. Let's go to sync. Oh, it's too fast. Sync. So you sync is to workspace, sim out. Choose this one. Yeah. So simulation output basically. And then you connect. And then I can call this Y, whatever variable name you call. It would put all those values in that variable for you. And then once you run, once you run, you can that variable should be created for you. All right. So now if you've done this, if you have done Simulink before a lot, at the end of that the lecture page 15, there's an example that has a controller in a PLD controller. If you haven't done, for example, a system that has step input in it and you want to see the output, you haven't done that in Simulink, pick one of the examples in the lecture, build that first. All right. If you have done that, you can solve the PID example. We will officially work on PID sometimes after spring break. All right. But for those of you that want to head start, you can do that. Yes. Yeah. It impacts because basically I'm all of this stuff. All right. So Zoom Classroom, do you know what modeling tab, modeling setting? So pick one of the examples, or I can pick the example for you. You can actually solve the one we solved, that I solved, that was very long. Build that and solve that. This one, I'll go to you, hold on a second. I think was this one. So solve one of these. The idea is to be able to build the model and run the simulation. So you have the values of K, right? Was 110, right? We pick the value, pick 100 here, 10 here, use a step input for disturbance. You can put a step that's 0, right? And then you will run another one that this one is 0, this one is a step, and see the scope for both of them to see what's the impact of that on system, right? For all the initial conditions, for integrator, put 0. Now, before you do that, I will show you something that makes your life a little bit easier. What's your question, Seth? Okay, let's do this one and then I'll tell you, because I know there is a problem with later generation versions that's a bit different. I'll tell you how to fix that. I remember that from last time I taught this. Now, if you had to build a transfer function, is everybody listening? So you don't have to actually build separately 1 over s and then times 2 gain. You can go to library and pick transfer function as one of your blocks. It's not here for me. It's one of the continuous. So you can go here and then grab a transfer function here, transfer function. And then double click and build your numerator and denominator. Then that becomes your transfer function, right? But put the transfer function of your plant separately from your controller. So don't mix them together, because your controller has a K that you will change that value. Yes. You can, because then you just have to connect it to your workspace that is like read vector A or vector, for example. Let me figure that out, see what version you have, because then I will. So this is output is different. I'll not lie, right? Here's what it's not run the simulation. Run this. This will run this. This is out, out and 1. So that will be I'm sorry. The out is your primary light. Now the out and why don't we get it? Why? If you're on the simulation, I think how about so out dot out is what it is. Whatever space you over, created. So for that generation, and actually will help you to.
And then actually saying this.
But you remember for this. All right, so good question from Seth. I'm gonna talk about that. So everybody please listen up while you're doing other things. So for the part that you read, you put your values in workspace here. So older version, you could just call it Y, but here you see that is out.y. So this is the structure. So when I run this, and it puts that in my out.y. If I go back to MATLAB, if I can find MATLAB, I have to, where is my MATLAB? Okay, here. So if you go to your workspace, you see that the structure being built, Connor, and here, this is important. So this is your out, this is a structure. When you open, you'll see that underneath, mine is loading. You should see Y out and then two other things, right? So does everybody see that? Yes? So if you want to plug that in your, no, don't let them in. This is just for the quiz. Kick them out. Yes. Just, so mine is slow. But if you click that, you will see Y out and two other structures. So if you want to plot, you have to say plot out.tout. Tout is time of simulation. So that's your time, structure of your time, comma, out.y. So out here is the parent structure. Tout and Y are the child in structure, right? So this is the way to call them in the workspace. So you want to always check how MATLAB is transferring those data to workspace. Previously, when it wasn't using object identification method, it was just object-oriented method. It would just be Y, and then you say T out and Y. Now everything is object-oriented. Basically, out is an object that has Y in it, has the simulation time, and all the other specification of your system. All right, so if you're using those values, check your workspace, see the structure, then use them. All right. Now I have a question from you that I need to answer. Any other question here before I give you passcode for the quiz? Yes.
How do you make a sum with?
I think if you add one more, like plus minus, it will create a third one. You can also add, yeah. So